Okay, last lesson in this unit and last lesson of the entire year. So congratulations, we're almost there. And we actually have three new definitions in this one. So we need to understand these definitions and we need to be able to work with them a little bit. They can be a bit confusing, but they're not too difficult. So if you practice enough, then you should be just comfortable with these, just fine with them. Let's make sure this pen actually writes. Yeah. So confidence intervals, you've probably heard this in studies before. Often you hear this in like political polling. It says, oh, we say the Liberals are 29% of the popular vote right now. This poll is within 98% accuracy 19 out of 20 times. You'll hear stuff like that. So when they give data, they actually say how often it's true. And that's what we're going to be talking about in this one. So the first definition, margin for error, is the possible difference between the estimated value and its true value. Okay, so the margin for error is how close to the number do you kind of guarantee the answer is going to be within? And I actually like to think of these in terms of z-scores. So if you have like your normal curve, um, sorry, my dog's barking. If you have your normal curve, then hold on, I have to correct her. All right, sorry about that. That only took a minute. So I like to think of this just like when we were talking about they were making the company making chords, and they have to say it lies within a certain interval. And if it's not within that interval, then they have to throw it out. So the margin for error is they say, oh, we say the result is right here in the middle, and we guarantee our result within a certain kind of goalposts. This is basically the goalposts. So I could set up my goalpost like here and here, and then I could say this is the margin for error, whatever that distance is, plus and minus. So if it's polling, maybe I'll say, oh, the Liberals are going to get 29%, and I'll say it's within 1.5%, something like that, on either side. So, it could have been 30.5, it could have been 27.5, but I'm saying it's within these goalposts. That's the margin for error. And then we talk about confidence. So how often do we think it's going to be within these goalposts? Now, we can't guarantee 100% of the time it's going to be within these goalposts, but we'll have a certain confidence based on where the goalposts are. So confidence interval is the range where your estimate lies. The range where your estimate lies. And that's what's the amount of data that's inside your goalpost, basically. Inside of goalposts. So the first one is how wide apart your goalposts are. The confidence interval is all the values that lies within your goalposts. And then the confidence level is how confident you are that this is true. How confident you are that this estimate is true. Now, the reason this gets so confusing is there's going to be a whole lot of percents thrown at you. So we're going to say, we could actually have 3 different percents all thrown at you in one question. So I could say the Liberals are going to get 29% of the vote, that my margin for error is within plus or minus 1.5%, and then my confidence level, I could say something like, I'm 95% sure that this is going to be true. So I actually have 3 different things that are true. 3 different percents about this relationship, so it gets really kind of confusing. So once again, 29% is my actual guess, and then my plus or minus 1% sets up goalposts. I say it's going to be this close to my guess. So how tightly am I going to be guessing that it's going to be close to whatever my prediction was? And then, how likely is it that the real answer is going to fall inside my goalposts? So this is kind of like the Z-score thing. So if I did 100 scenarios, how often will it actually lie within this goalpost that I set up? So 95%, maybe there's some odd times that where it's like way off and your prediction just wasn't even true at all. But most of the time it should be very close to your goalpost is kind of the idea. Okay, let's see it in work. And we're just going to do 2 examples, I think, 1 and 2. Because it's mostly just about understanding how they play off of each other. So a telephone survey of 600 randomly selected people was conducted in an urban area. The survey determined that 76% of people from 18 to 34 years old have a social network account. So they're just trying to find out who has a social network account. I don't know which one. What's most popular these days? Snapchat or something? So they asked everyone from 18 to 34 years old, and they guessed. So this is the middle. This is kind of like your mean, if you want to think of it like that. These numbers don't really apply anymore because we don't have an actual data set. This is more about guesswork. But if you were going to think of it like a normal curve, this would be the middle. Our guess is it's 76% of the time. Now, the results are accurate within plus or minus 4%. So that's our margin for error, and that sets up our confidence interval. So both the first 2 definitions kind of fall from this number. And then this last thing, 19 out of 20 times it falls within 4% points. So sometimes it doesn't even fall within 4% points, but almost every time they do it, if they did this actual survey like 100 times, 19 out of the 20 times, it was somewhere, the goalposts were 4 degrees on either side, it was somewhere in that range. Okay, so let's see if we can answer questions. Calculate the range of people that have social networking accounts in an area where the total population is 92,500. Okay, so what are we actually asked to do here? So they want the range, so I'm going to actually calculate the confidence interval. So we know that 76 should be in the middle, and we can add and subtract 4% from there. So it should be anywhere between 80% of the population and 72% of the population. So really this is where my goalposts are. Somewhere between 72 and 80 is percent of the population should be having this. Calculate the range of people. So we want to know how many people are actually in here. So instead of doing it as percents, we're going to do it as an actual population of the town of 92. So we would say the range is somewhere between, so 0.72 times 92.5. I have to get a calculator out. .72 times 92.5 is 66,600. So my first goalpost, I'm saying almost all the time there's at least 66,600. And then my last goalpost is 80%, so 0.8 times 92.5 is 74,000 people. So it should be somewhere between those numbers, almost all the time. Anything else we need to talk about that one? We could have said the middle of it, and that would have been another way of doing it. We could have said it was 76% of that, and then plus or minus a certain amount. But this is fine as well. So there's a lot of different ways to do it. Determine the certainty of the results. So this is true 19 out of 20 times. They always label it this way. I don't know why. I think putting this one as a percent maybe confuses people because there's percents here and there's percents here. So maybe they do this one as an actual fraction. So it is 19 out of 20 times it lies inside our goalposts. And what is that as a percent? Well, that's 95%. I assume we know how to do percents. Just divide and then times by 100. That's it for this. So you just need to be able to interpret all this data and make sure you can kind of talk about confidence ranges. Okay. Next question, and I think last question. Yeah, this is a big one though. Let me make it a little bit bigger here so we can read it better. Polling organizations in Canada frequently survey samples of the population to gauge voter preference prior to an election. This is kind of one of the most classic examples of it. People are asked, if an election were held today, which party would you vote for? If they say they don't know, then they are asked, which party are you leaning most towards? The result of 3 different polls taken during the first week of November 2010 are shown on the next page. So this is probably real data, actually. It's not the next page, same page, if you have the same sheet as I do. Well, maybe it's the next page for you guys. No, I think it's on here. The results of each poll are considered accurate 19 out of 20 times. So every single poll is 19 out of 20 times accurate. I think this is how they set up the goalposts. I think they always want it to be 95% of the time accurate, and then they set up the goalposts based on that. It's like your Z-scores. You want to set up the goalposts around the middle so that 95% of the population is on the inside. I think that's exactly how they find the margin for error. Otherwise, that would be too much of a coincidence that every single poll had the exact same confidence. So that is our confidence, what's the definition for it again? Confidence level. So that was our confidence level. And once again, that's 95%. Okay, so we have that if we need it. So let's look at it. These are the companies. So the company Ecos, they surveyed 1,815 people. They said they had a margin error plus or minus 2.3% for every single result. And they have every single party and how much of the vote they seem to have gotten. Then same thing for Nanos. They have a much smaller population and a much bigger margin for error, and they have their data, which is a fair bit different. Definitely with the conservatives, it's significantly different. The other ones are a bit closer. And then Ipsos, closer to Nanos, but a little bit, it's kind of in the middle. Its margin for error is in the middle, and it was in the middle for this result, with the low one low. So a lot of different data here. The margin for error in the reported results. This wants to talk about how the sample size affects it. How does the sample size used in a poll affect the margin for error in reported results? Well, the easy answer is larger sample size equals smaller margin for error. Right, because we have the biggest sample size has the smallest margin for error. The smallest sample size has the biggest margin for error, which makes sense. This just goes with our stuff from probability. The more people you test, the larger your sample, the more accurate you're going to be. So that makes sense. How does the sample size affect the confidence interval? Well, the confidence interval is going to shrink then. So larger sample size, we'll call that LSS. So the larger sample size equals smaller interval. So maybe that seems counterintuitive. It's because the smaller the interval is, confidence interval, that means the more precise your results are, because that's how wide your goalposts are. So if you have a really big sample, then you can move your goalposts really, really close because you think you're quite accurate then. Okay, and then we could do a whole bunch of things. Let's actually calculate what some of these intervals are. 33, what did they actually do here? I don't know what numbers these are. Oh, they used this one, and it went from 33. Yeah, so they were doing the conservatives. Let's look at the intervals for the conservatives. So we have E company, and their interval is going to start kind of at 37. No, this is E, 29, sorry. So they start at 29 and they go 2.3 to either side. So their confidence interval is 2.3 either way. If I add 2.3, I get to 31.3. If I take away 2.3, I get to 6.7, 26.7. And so the whole range is going to be double 2.3. So it's a range of 4.6. So range is just like what we were doing before. Top number subtract bottom number. Actually, I don't think we were doing. I think my other class did that. Anyway, we'll just do one other company. We'll do the smallest one now. So versus the N company, for the conservatives, they had it pegged at 37, and they said it goes anywhere between, add 3.4, so that goes up to 40.4, and take away 3.4, 7, 6, 5, 4, 3.6, 33.6. So they said it was anywhere in there, which is a range of double 3.4, so 6.8. And the sample sizes, this was 1815, this was 844. So you have much tighter data with the E. Now, if you're anything like me, you're probably asking yourself, how can this company guarantee that the results are going to be within these two numbers 95% of the time, when this company up here guarantees the results are going to be within these two numbers 95% of the time? There is no overlap at all, and so basically that's impossible. These polls, they put a lot of numbers up here, but these are just kind of, you can't always trust numbers, especially when it comes to polling companies. They might be surveying only in certain areas. They might be surveying to try and pursue a bias that they have. There's a whole bunch of reasons why it's bad, but this is definitely not true. One thing we can say for sure is both of these people cannot be right 95% of the time when it comes to the conservative numbers. If there was a bit of overlap, then maybe. Like if this one went up to 32 and this one went down to 30, then maybe they could both be right 95% of the time, if almost all the time the actual poll is between 30 and 32. But this one, there's no overlap, so it's literally impossible. They cannot both be right 95% of the time. So just bad data. Actually, I think I lied. I think I want to do one more question with you guys. How long has this video been? 19 minutes? We'll see if we can do this kind of quick. Okay. So to meet standards for baseball, they have to have masses between 142 and 149, and with an average mass of 145. Makes sense. To ensure that production continues to operate as expected, the quality control engineer takes a random sample of baseballs each day and measures their mass to determine the mean mass. If the mean mass of the random sample is 144.7 to 145.3, then the production equipment is running correctly. So we have two different ranges here. This is a much tighter range, and that's for the mean one now. If the mean mass of the sample is outside of those levels, then the production equipment is shut down and adjusted. The quality control engineer refers to the chart shown when conducting random sampling. So if they sampled 110 of the balls, then they can be 99% confident whether or not it's within the right range or not. With only 65, it's 95%, only 45, it's 90%. What's the confidence interval and margin for error the engineer uses for quality control tests? 144, so we're going to use these numbers right here. So in their quality control tests, what's halfway between those two numbers? It should be 145. It should be the same as the average. So the middle is at 145, and it goes down to 144.7, and it goes up to 145.3. Okay, so what is our margin for error? What's the amount of these dashes? Well, it's actually fairly easy. It's just 0.3. That's plus 0.3, and that's subtract 0.3. So margin for error is 0.3 grams, plus or minus. Okay, and then what's the confidence interval? That's just this range. So it's just 144.7 till 145.3. These brackets mean it's all the numbers in between these numbers and including them if they're square brackets. So this is just setting up, it's like looking at a number line. It says start your number line at 144.7, continue it to 145.3. Those are all the answers you're looking for. With square brackets means including those numbers. Interpret the table. We kind of know what this means. We talked about this already. If he samples 110 of the baseballs, then 99% of the time, so there aren't only 110 baseballs made. We have to think this is a company is producing out thousands of baseballs. Does it say how long it takes? Maybe in an hour. Let's pretend it takes an hour, and they make 1,000 baseballs an hour. So if he picks up during that hour 110 of the baseballs, and takes all of their weights and weighs them, and finds the average is somewhere in this range, then he can be 99% sure that the machine is running correctly, that most of the balls are being produced correctly. That's what that means. If during that hour he only pulled out 65 baseballs and he calculated their average weight and it was somewhere in this range, then he can be 95% sure that the equipment's running correctly and that almost all the baseballs are correct. And with only 45, he's only 90% sure. So 90 really isn't probably good enough. You probably wouldn't want your quality control person only doing 45 balls an hour. So that's what that means. We'll skip the rest of that. What is the relationship between confidence level and sample size? We've asked this question twice now, so this is a dead giveaway that this is going to be an important question. And this comes from grade 8 probability. So larger sample size equals more confidence. So either one of two things improve if you have a larger sample size. Either you can move the goalposts, this is what we did in the previous lesson. If you have a larger sample size, then you can move the goalposts closer together and remain with the same confidence. So you can say, oh, I can make this tighter now, and still, it was here originally. I can say, oh, I can make this in here now because I have a much bigger sample size, and I can still be 95% sure that it's within my new goalposts. So you could do that. Alternatively, in this one, we kept the goalposts where they were. So we kept the goalposts at red, But we said if we have a larger sample size, we can be more sure that it's inside the red goalpost now. So with a small one, it was only 90% sure it's within the red. With the big one, it's 99% sure it's within the red. So one of those two things gets better if you have a larger sample size. Sometimes both of those things. But yeah. Okay, that's it for this lesson. You have a big task ahead of you. You need to practice these ones. There's only a couple questions here, and maybe you can even rule out. So I would either cut out like number 2 if you think this is easy, or cut out number 10 if you think this is hard. And then you need to start doing your test review at the back of the book. And this time, I think I'm going to ask you to hand it in. Because I'm going to be frank here. You guys could be doing better. I like how much attention you're paying in class and when we're working kind of one-on-one together. I think you guys are doing a great job paying attention, asking questions, trying to figure it out. But you have not been practicing nearly enough. When I'm not working with you guys, you're wasting most of class time. And that's the difference between, you could be getting in the 70s for these units easily, probably. And if you practiced a good deal, then you could easily be getting in the 80s, possibly, on some of these maybe later units. But you just haven't been putting in the questions yet, and your marks have still been kind of lower than that. So I want to get it better for this one. So this class, maybe you only try 2, because I really want you to do the entire practice test in the textbook and hand it in. We'll call it chapter review. Chapter, I forget which one this is. So you have homework, hand in as much as you can do of it. If you were 80% done it, if you can do like half of it in class and half of it for homework, but you didn't do all of them, you didn't understand a couple questions, that's great. That's what I'm looking for. That's not bad. If you could do all the questions, that's even better. If you don't do any of these questions, that's going to be very disappointing. So make sure you try them. This is the end of the year, so we need to start pushing hard. Okay, good luck, guys.